Hi there, in this video I'm going to show you how to quickly create rig controllers for a humanoid character. First, open a new scene, and here you'll have to import your character in either FBX or DAE format. Cascadeur already has a set of template controllers and supports a wide range of standard skeletons. For example, characters from Unreal Engine, DES, Mixamo, Character Creator, MetaHuman, Ready Player Me, just to name a few. And it will literally take less than a minute to rig one of them. So let's check them out first, and then later in the video we'll talk about the things you need to know when working with custom models. So to start with, go to File, Import FBX/DAE Model. Say I have a character from Unreal Engine, which is a standard model that Cascadeur has a template for and fully supports. Once you click Import, a dialog box appears and suggests that you should go into the rig mode. Also, Cascadeur recognizes it to be a humanoid character and offers to launch the quick rigging tool. This dialog box tells you that the character has been fully recognized. And we can see that because all the points of the character have been automatically assigned and show up as blue. Now simply click Add Rig Elements, and you'll find the character to have a set of rig controllers along with a physics skeleton. So click Generate Rig, and it is done. Now you can animate your character, or you can make further adjustments to the current rig if you need to. We will talk about the ways you can do that in the next part of the video. If you're using a custom character which is not supported by default, you can assign the rig controllers manually. Here I have a set of characters that I'm going to use to demonstrate the cases that you might face when using the rigging tool. Some of the characters can be found in the sample scenes, others were taken from open resources or provided by users for this tutorial. So in order to set up rig controllers, the model has to have a joint skeleton with a mesh already skinned to it. You can display the skeleton in the joint view mode. If your model doesn't have a joint skeleton, or if the mesh is not skinned, that is, if the mesh doesn't move along with the joints, so you will first have to create such skeleton and skin the mesh to it. You can use any software which does it. Currently, skinning is not featured in Cascadeur. Characters have to be positioned in a symmetrical T pose or an A pose. Also, pay attention to the scale of your model. Characters may be of different sizes. This robot, for example, is meant to be rather big, but if your model is going to be too big or too small, you might find it problematic to work with this character. Also, autophysics tools will not work properly if your model is not up to scale. The average model size should be roughly the same as an average human. However, the model might have been made in a software with different working units, or the scale might have been changed during the export. So the best thing to do in that case will be to change the model or export settings directly in the software where it was made. You can also check the model scale with transforms. Locate the first joint or any root joint in the skeleton hierarchy, and open the Transform tab in the Object Properties. It will be very important to have local scale parameters set to 1. That would be ideal actually. You can, however, increase or decrease local scale, and this way change the size of the model to make it easier to work with in Cascadeur, but the problem is that it might potentially cause issues or lead to additional steps if your pipeline includes transferring this animation between certain engines or software where local scale parameter could be important. By the way, if local scale initially was just a different number, say 100 for example, there is no point just setting it to 1 in Cascadeur. Rather, set a value with which the model would be roughly of an average human size. So the models that we have here are all set. Now let's go into rig mode by clicking this button. When in the rig mode, you can now create rig controllers. Since this one is a humanoid character, the best way to create rig controllers will be to use the quick rigging tool. However, this is not a standard skeleton, so the quick rigging tool hasn't recognized it. Well, not fully at least. And you can see that because most of the points are grey. So you will have to manually allocate the joints to create the controllers. Let's start with this character, shall we? Click the name of the joint on the list. The selected joint will also be highlighted in the viewport. Click and hold left mouse button to drag and drop the joint onto the corresponding point on the scheme. That point will turn blue. And also the name of the joint will appear on the list of the controllers on the right. Next we go and assign the stomach, chest, neck and head. However, you can assign joints in any order you want. It doesn't really matter. Different characters may have different number of joints in their spine. If the character has less joints than the controllers on the scheme, it's okay to leave some points grey. This character, for example, doesn't have the joints for the stomach and the neck, so these points will remain grey. And this one doesn't have joints for the head, which is okay. However, auto-posing will not work with rigs like that, because auto-posing requires all the controllers which are present in the quick rigging tool. The other case is when you have more joints in the spine of the skeleton than points on the scheme. Using the quick rigging tool, you can only create standard rigs which have 3 controllers in the spine, meaning in such rigs you will be able to control the pelvis, stomach and chest. So the key here is to assign the joints that correspond best to the location of the body parts mentioned. You can rotate the joints in the viewport to see what influence they have on the mesh. Just make sure to press Ctrl Z to revert any changes. Same way you assign the controllers for arms and legs. This can be done for one side only, left or right, and then mirrored. And again, the character may have all the joints for all the controllers, say clavicle bones, shoulders, forearms and hands. But if clavicle bones are missing, like in this one, the rig will still work. However, having shoulders and forearms assigned is critical. That's why their corresponding names are marked blue. If the character has a weapon in either hand, don't assign it just yet. If your character has fingers, go to the left or right hand tab, depending on the side you assign the rest of the body to. Assign the fingers the same way as you did with the rest of the body. If your character features less than 5 fingers, you can still assign them, but the auto-posing for hands will not work in that case. But you'll still be able to animate them using the box controller instead. Also, some characters feature twists in their hands and legs. Twists are the intermediary joints which will automatically rotate with the corresponding controller. They provide additional rotation so that the mesh would look better. Now, when you have all the controllers assigned for one side of the character, you can simply mirror them for the other. Check the naming of the joints for the left and for the right side. In the original box, you have to put in the prefix of the side of the body, the joints of which you have already assigned. That should include all the symbols, like underscore in this case, and it is case sensitive. In our character here, we'll simply have underscore R for the right side and underscore L for the left. Since we've allocated the joints of the right side of the body, we put _R in the original and _L in mirrored, and click Create Mirror Object. If done right, the points on the other side of the body should turn blue. Another example, in this model we have words left and right in the naming of the joints spelled with a capital letter. So we put right in original and left in mirrored. Same goes for any other naming. Characters may be holding objects or weapons. So in this tutorial we'll focus on the most common case scenarios. This character here has a rigged weapon, the root joint of which is parented to its hand. In this case, simply drag and drop the joint of the weapon in its respective slot. But what if you don't have the weapon and you have to add it into the scene? As an example, I'm going to use this Unreal character, which is already fully rigged. Right now, we are in the animation mode. To import the weapon, go to File, Add FBX/DAE, Add Model. The weapon shows in the viewport. However, if you go into the rig mode, it will disappear. The reason it happens is because the joints of the weapon have not been added into rig info. Now go back to animation mode, select the joints of the weapon, this one only has 2. Now find rig info in the outliner. Hold Ctrl and click it to add it to the selection. Now go to Commands, Rig Info, Add Joints. Now when you go into the rig mode, you can see that the sword is now visible, and we can create controllers for it. Once all the controllers have been assigned, you can now generate the rig. So click Add Rig Elements, and you will see the rig displayed in your viewport. However, it might still require some adjustments. You can switch to animation mode now and see if the controllers work properly. We can use auto posing with this character since all the controllers have been assigned. And you're free to use the point controller mode as well. However, for this character, auto posing will not work because it doesn't have enough joints to create all the controllers necessary. So you can use point controller mode instead. Check the position of the endpoints of the rig. It is much more convenient to work with if the endpoints match the geometry. Check here for instance. The head rotation controller is located too close to the neck, which sort of makes it a little bit awkward to use really. To fix that, go back to the rig mode, use orthographic view, and stretch the point out. Now it will be much more convenient to rotate the head and track its trajectory. However, you should never move points which are in the middle of the chain. That will lead to awkward behavior and unpredictable results. You should only move additional points or direction points at the end of the chains. The position of the points will also affect the auto-posing tool. The closer they are to the default model, the better auto-posing should work. Let me show you an example. If you move the top of the head point forward, the character will start tilting the head back. Because auto-posing assumes that in a standard pose, this point should be on the top. Same goes for the hands. Make sure the direction point goes towards pinky, while the additional point goes towards the index finger. However, if you don't work with auto-posing, that is not that critical. However, it might still be more convenient for you to work with the standard placement of the hand controllers, since it's easier to use pivot points or track the trajectories. And last but not least, the feet. First, I'm going to stretch out the direction controller closer towards the edge of the foot, but then here look, there is a hinge. That means 2 points connect there. Now if you move only 1 point, the connection will break, so make sure you select both. You may also want to change the scale and weight of the rigid bodies, since that will influence the character's physics behavior. To do that, select the rigid body and go to the Physics tab on the right. Here, you can set the mass of the rigid body. The values that you see there by default are the ones of an average human. For the huge robot that we see here, I should definitely opt the mass. Same way, you can change their shape and size. Use the mouse wheel to change the values. And with this particular model, you'd probably want to do that with all the rigid bodies you have. For the limbs, make sure you focus on one side only. When adjusting rigid bodies in the limbs, it will be much easier to then mirror them to the other side. But we can't use the quick rigging tool to mirror the values of the rigid bodies, because if we do, it will essentially generate the initial rig and we'll end up losing all the changes that we've made. So to do that, you have to use the normal rigging tools instead. First, you have to delete the rig elements of the other side. Double-click the base points of the limb to select all of the elements and click Delete Rig Elements. Then, in the Mirror Group tab, put in the required naming in the boxes and choose the mirror plane. Then, double-click to select all the elements of the limbs and click Create Mirror Object. Some characters may require even more detailed adjustments, including having additional body parts added. As a rule, we do not recommend adding extra rigid bodies for the elements that do not significantly affect the character's center of mass. Should that be elements of clothing, for example, or facial features? Adding rigid bodies for parts like chin or nose or tongue would have made the rig unnecessarily heavy and difficult to work with. So for parts like that, it is best to use box controllers instead. Also, box controllers may work separately from the physics skeleton, and thus will not influence the physics behavior. To make one, make sure only box controller is checked. Then, select the joint that you want to control in the viewport. By the way, I can also rotate it to see if I chose the right one. Just make sure you reverse any changes that you made by pressing Ctrl Z. And now click Add Rig Element. Now a box controller has been created for the selected joint. You can move, rotate and scale the box controller using the corresponding tools. Same way you can add any box controller in the rig. But there might be cases where you would want to use physics tools for the specific parts of the character. Say, I want to be able to use secondary motion for this character's ears. In this case, only box controller should be unchecked. Select the joint and click Add Rig Element. Check the position of the additional point. I think I'll move it somewhere like so. You can set the axis for the additional point here. But we're not done yet. If you switch to animation mode now and try to use auto posing, you would notice that the ears would actually fall back. It happens because auto posing only controls the points of the head, and the controllers that we've just created behave as an IK by default. It feels like as if I were moving the character without having those points selected. To fix that, return the character back into the T-pose by selecting all the box controllers and go into Commands, go to T-pose. Now go to point controller mode, select the points of the ears, go to point IK FK settings and set their behavior as FK. So when you move the head now, the ears will follow. Once all the changes have been done, you can export this rig so you could then easily apply it to your character. For example, if you have an FBX file with your character's animation, you can quickly apply this rig and get straight to tweaking the animation. But it's important to mention that the rig controllers that are used in Cascadeur cannot be exported into software with other rig systems. Also, once the rig is created, I can simply save the scene to use it as a starting scene for any animation. This way, I will only have to remember to save the scene as a new file for every animation. And that's it. I hope this video was really useful. Make sure to check out Discord community to ask any questions, get the latest news, or maybe share your work with others. Thanks for watching, and I'll see you next time.